All right, in this video, we're going to talk about some compositions of trig functions and inverse trig functions. Sometimes it follows the basic rule for a composition of inverse functions, and that's going to happen like in these first few examples where the inverse trig function is on the inside and the regular trig function is on the outside, and they match each other. So this is going to be inverse cosine on the inside and cosine on the outside. We're allowed to get mismatched ones where I would say find the tangent of the arcsine of something, but usually those things that are on the inside are going to be things that are on the unit circle to help you draw your triangle. Not always. Sometimes you're going to have to just draw a right triangle and use the Pythagorean theorem to answer the question. But all of these are very basic. I won't have to be doing that in any of these examples. So this one, they're just going to undo one another. And this one, they're going to undo one another. Remember that you need to stay within your range of your sine and cosine functions, that the thing that you're finding the arcsine or arccosine of needs to be between -1 and 1. Otherwise, there's no answer. Arctangent can be anything between -infinity and infinity. So there's that. I'm going to skip these other ones for a second because I'm going to need to draw things over here for them. I'm going to go straight to this one. And I think, yep, that's the last one that's like that. There's only 4 of them like that. So now when the regular trig function is on the inside and the inverse trig function is on the outside, like these other ones that I have left, I need to draw a picture and make sure that I know what quadrant I'm in. So cosine of -3 pi over 5 is going to be down here in quadrant 3. -3 pi over 5 is over here because it's -3/5 is -0.6, which is less than -0.5. It's further in a clockwise direction from that. So we need to be in quadrant 3. Now, our cosine doesn't return an answer in quadrant 3, so I need to have the same reference angle here. This is 2 pi over 5 as my reference angle right here to get me up here, and I need to have that same reference angle over here, but I need to return this angle that's measured from 0 to 2 pi over 5 away from the x-axis. So let's see what that is. Pi minus 2 pi over 5 is 5 pi over 5. Minus 2 pi over 5 is 3 pi over 5. Again, some of this is because this is an even function, and we went in a negative direction, that if we had gone around in a positive direction instead, it would have worked out, but this comes out to be 3 pi over 5. Exactly. So let's go ahead and draw our picture for the next one, that we have tangent of 5 pi over 7. So that is closer to pi. It's past pi over 2. So 5 pi over 7 is here. Our reference angle here is 2 pi over 7, but we're not allowed to return a value of arctangent in quadrant 2. That negative tangent value needs to be down here in quadrant 4 with the same reference angle. So it needs to be -2 pi over 7. For sine of 4 pi over 7, that is just slightly bigger than pi over 2. So I'm over here. like that. And again, our sine value is positive in quadrant 2, so I need to use the value in quadrant 1 that also has a positive sine value, so I need to look at this reference angle of 3 pi over 7. That's what I need to return. Now let's look at cosine of pi over 10. That's going to be in quadrant 1, so nothing special is going to happen to that, because when I take this angle, that this triangle here, it's going to return a positive cosine value in quadrant 1. So I'm going to stay there in quadrant 1 for that. Sine of pi over 5. So that again is in quadrant 1. So when I return the arc sine of that, I get the same angle, pi over 5, and arctangent of negative pi over 8. Negative pi over 8 is in quadrant 4, which arctangent is allowed to return a negative angle from quadrant 4. So we just return that. Okay, that's it for these compositions. I'll draw one picture here for something that is just a little more complicated, because you will get these things. So let's say that I have something like arc sine of the cosine of pi over 6. Okay, so let's draw that triangle. Here's pi over 6, and the reference triangle here is going to have 1, √3, and 2, like that. So this is going to be arc sine of cosine is going to be √3 over 2. Then I need to ask myself, okay, where is the sine value going to be √3 over 2? It's actually this other angle right up here. This is going to be pi over 3, because this angle up here has an opposite over a hypotenuse of √3 over 2. So you may get some things like that where you're able to simplify the inside, and then you need to find the arc sine or arc cosine or arc tangent from there. You may need to draw some triangles. You may not find everything right away on your unit circle. Let's try one more example here, where I have something like this. Where I have arc tangent of 3 over 4, and I want the sine of this. So let's draw a triangle whose tangent is 3 over 4, and let's replace this arc function with the variable theta, and then say, well, this is by the Pythagorean theorem. A 3, 4, 5 right triangle. So the sine of theta is going to be opposite over hypotenuse. And you may get some things like that as well. We're not, we've only done some basic ideas of inverse relationships here, but don't be afraid when things don't match like that and you have to draw a triangle. All right, that's it for this video. We'll come back next time and we'll solve some equations using inverse trig functions.